simplify this MODI method, the logic behind each and every step, few people feel the MODI method is some complex, and by finding initial basic feasible solution it would be done. That's a wrong. MODI method actually helps us to minimize the transportation cost even further. The first solution we identify, we obtain as IBFS through three methods: NWCC, LCM, Google approximation method gives you a solution. Whether the solution is feasible or not, and even we can minimize the transportation cost, we can know the answers to these two things by applying the optimality test. We have two tests to check the optimality. The first one is stepping stone method and second one is MODI method, abbreviated as modified distribution method. The name says that we change the distribution of allocations in the given transportation table. By that we can minimize the transportation cost. Whatever it may be the method you identified, the IBFS, we can minimize the transportation cost. In easily NWCC, if you identify one solution to a given transportation table, that can be minimized by LCM. The cost difference between these two, LCM is comparatively better when compared to NWCC, and even Google approximation method is comparatively best when you compare to these two methods in the perspective of total transportation cost. Now we see the step-by-step procedure and algorithm of MODI method. Firstly, step 1, arrange the data in matrix form, that is payoff matrix form. Then the next step 2 will be check for whether the given transportation table is balanced and minimization case only. If not, then add a dummy rows or columns to make it balanced. Where supply and demand must be balanced, and also if it is a maximization problem, convert it to the minimization problem by subtracting the highest element from each and every corresponding row. After this, in step 3, find out IBFS. This is unbalanced and maximization case. This is matrix form. Find out initial basic feasible solutions by using your own required methods of any these three: NWCC, LCM and Google approximation method. With the step 3, you are actually with a solution. Now our task is to identify the given solution is feasible or not. In this step, you are with a transportation cost. You find out the total transportation cost. Is it a final, and you can decrease it further. That is, we know it by furtherly MODI method. The MODI method starts from step 4 onwards. The transportation problem consisting of a solution, 2 phases. This all up to step 3 is a phase 1, where arranging the data and converting or finding out IBFS is step 1, phase 1. In a phase 2, we check the optimality of the given transportation routes. That means the solution, the optimality of the obtained solutions. So what is the step 3? Now this being crucial, this up to phase 1. Now step 3, divide the table into this occupied and unoccupied cells. For the occupied cells, identify this Cij values. How can I identify the Cij values? Cij values again you identify by using this Ui plus Vj. But what about this Ui plus Vj value? What is this? Let me explain. And after for unoccupied cells, you also identify this Dij. Dij equal to Cij minus Ui plus Vj. Also for unoccupied cells, we find out this opportunity cost. Dij indicates opportunity cost. And let me explain this UIS and VJS. For all I equal to 1, 2, 3 and so on. For all j equal to 1, 2, 3, 4 and so on. This I represents the total number of sources we have. J represents the total number of destinations we have. For example, in the given problem, we have 3 sources and 4 destinations. Then this can be like. For all the given cells in the table, this Ui comma Vj values are being calculated. How can we calculate them? Once you calculate this one value, then from there onwards, arithmetically we can calculate all of them. Where there is a number of allocations, there assign Ui or Vj value as 0. And also few people follow simple technique. Initially Ui equal to 0. This is done. Thus after finding out, the only one criteria we need to meet is all Dij values must be greater than or equal to 0. If we get all Dij values, then you reach the optimality solution. All the Dij values you identify for all the unoccupied cells, you identify this value. This value is called opportunity cost value. How can you calculate that? So corresponding Cij minus this Ui plus Vj values. How can I find out this Cij values? Cij values you can identify by Cij equal to Ui plus Vj. And how can I identify this Ui plus Vj values? Again, go back to again. Like assign arbitrarily, we can find out Ui plus Vj values. That's all for all Dij greater than or equal to 0. If not, then find out the largest negative value among all Dij values. From there onwards, construct a closed loop path. And alternatively assign the signs. From the negative cell element, select the largest least element. Where there is a positive sign, add it. Where there is a negative sign, subtract it. By this, the allocations can be changed. By that, the total transportation cost change. As I previously said, Modi method is to check the optimality and decrease the given transportation cost. The transportation cost, how can I identify this transportation cost? Here, that is units into unit cost. Is that it is? Either I have to change unit cost or I have to change the units. Unit cost is clearly given and according to the given algorithm I follow. And units This get exhausted. Now move on to the next northwest cell in the table, that is S1 D2. Here 120 and 20. In this when condition satisfies 0 and this becomes 100. Next this get exhausted and the next northwest cell becomes this 100 and 160, 100. This becomes 0 and this is 60. This get exhausted and the next northwest cell is 18. This is 60. Negated here. This becomes 0. This is 90. This row get exhausted, deleted. And the next last cell is 90. This is 0 and 0. All of the supply and demand get satisfied and get exhausted. And I allocate my total allocations are this S1 D1, S2 D2, S1 D2, S2 D3, and finally S3 D3. Now check the degeneracy. M plus n minus 1. Your total number of allocations must be equal to this particular one. That equal to 3 plus 3 minus 1. That equal to 5. Total number of allocations you must get is 5. 1, 2, 3, 4, 5 is the total allocations I get. This is the solution of a given transportation table by using northwest corner cell method. Now find out the transportation cost. That is transportation cost 16 into 180 plus 20 into 20 plus 8 into 100 plus 18 into 60 plus 90 into 60. After first phase of the solution, by solving northwest corner cell method, we are with the allocations. Check whether it is a degenerate or not. We check it by m plus n minus 1. That equal to total allocations must be equal to 5. That I got totally 5 allocations over here. Now divide the table, the way of table into 2 parts. That is occupied and unoccupied. Simply occupied means where there is allocations. Unoccupied means where there is no. In the first row, this S1, we have 2 allocated cells and 1 non-allocated, that is unoccupied cell. In the second row also, simply refer or call that cell with their cell references. I am calling them first. In the first row, I am writing occupied cells. Occupied one. Then that is C11 equal to the C11 is an occupied cell. Secondly, C12 is occupied cell. And next we have in the first row it is over. In the second row I have C22 and C23. And the next in the third row we have only one allocated cell, that is C33. Now find out these values by using the given formula called Cij equal to Ui plus Bj. The economic values of Ui, Bj values are identified in this manner. Like U1, U values for each and every capacities we have, sources we have. U1, U2, U3. We have 3 sources. Similarly, V1, V2, V3 for the destinations we have. Firstly, take this U1 value as 0. Then next from there onwards calculate. C11 value by using this formula, C11 value equal to this value related U1 value comma V1 value. This U1 plus V1. C12 value related to U value U1 plus V2. Related to C22 value U2 plus V2. U2 plus V3. U3 plus V3. Now find out these values. Here C11 value equal to U1 plus V1. This U1 is already 0. Then by adding of what value, the C11 value becomes the 16. Then V1 equal to 16. This is 16. With this 16, take help of the V1 value, fill any other allocated value. So this V1 may not be useful in any, just because this 14 and 26 are non-allocated cells. Now move on. With this U1 value, you can fill any other value. Yes, I can fill this another value called this second one, S1, D2, U1 related to U1, and this one is also 20. 20 plus 0 equal to 20. Now the next allocated cell is this 8. You need to get 8. One of the values is 20. By adding or subtracting of what value, this cell value becomes 8. 20 minus 12. That equal to 8. Now this value 18. You need to get 18 value. Then make a changes to U, comma V values correspondingly. This 18 corresponding U, comma V values are this U2 and V3 correspondingly. One of the values is minus 12. By adding or subtracting of what value, this becomes 18. So this might be 30 minus 12, that equal to 18. Now you got the last one cell of the table, that is this S3, D3. You need to get 16. The corresponding U, comma V values are U3, comma V3. Already V3 value is 30. By making of what value, by adding of what value, this becomes 16. 30 minus 14, that equal to 16. The logic is here simple. Where there is an allocated cell, then find out the corresponding U, comma V values. By adding the corresponding U, comma V values, you need to get that cost value. That is. So what are the obtained values here? You need to get 16, that you got U12 value, 12 value 20. So U1 value 0 plus 20, that equal to this is 20. And C22 value is 8. Then we got it by U1 value minus 12 plus 20, that equal to 8. Now C23 value is 18. How you got this 18? By corresponding U value is minus 12. Corresponding V value is 20. Minus 12 plus 2. Sorry. C23, 18. 18. Now you got minus 12 plus 30. The last finally one, C33 value is 16. So minus 14 plus 30. That equal to 16. This is for occupied cells. Now we need to find out the values for unoccupied cells also. From the table, unoccupied cells are this one called S1D3, S2D1, S3D1 and S3D2. For them all, we use this one particular formula called Dij equal to Cij minus Ui plus Vj. By using this formula, we find out for all unoccupied cells an opportunity cost. All unoccupied cells values must be greater than or equal to 0. Then that is the optimality or optimal solution. If not, then make a changes to the given solution, change the distribution, and then find out the another transportation schedule. Now occupied cells are over. Then move on to unoccupied cells. Unoccupied cells. Firstly, notice them. That is D13 and then equal to next D21 and next D31, D32. That's it. 1, 2, 3, 4 and occupied first value is minus 18. You can simply, don't need to be worried about remembering all these values. Remember the cell location 2, 1. That means C21 minus U value is U2 plus V value is plus 1. Or simply look at that cell C21, this 21 corresponding C value 14, cost value 14, corresponding V value is this U2, this cell U2, and corresponding V value is 16, this one. You have to move horizontally and vertically to find out U comma V values. The C value, cost values are present over there. That equal to the C21 value is 14 minus U2 value is minus 12 and V1 value is 16. 14 minus 4, that equal to 10. Now this C31 minus U3 plus V1, that equal to C31 value. V1 value is 26 minus U3 value is minus 14 plus V1 value is 16. 26 minus 2, that equal to 24. The last one value C32 minus U3 plus V2, that equal to C32 value is 24 minus U3 value is minus 14 plus V2 value is 20. 24, this is 6, 24 minus 6, that equal to 18. Now we got all of these unoccupied cell values. These are the important to make the closed loop and change the allocations, distributions. From all of these values, verify all of these are greater than or equal to 0 or a positive value. Wait, we have one negative value, that is 18. If you have more than one negative value, then select the largest negative value among them. So 18 is selected, we have 18 and D13 is the selected cell, is the entering variable. Now in D13 we have to make allocations. By that the total transportation cost can be decreases. The total transportation cost can be decreased with the multiplies of 18. That is. So that is D13 is this particular cell, selected cell. Now construct a closed loop path, start and end over there, start and move through the cells and also reach over here. By that you can construct a closed loop path. I am moving this left hand side and again down and again and this. The only one thing is you have to move on with all the occupied cells. From there onwards, move on with the all occupied cells and again reach. Start from the entering cell, that is D13, and move on like all the unoccupied cells and then reach the same cell where you started as a closed path. Where you started, that cell represent, put a sign positive, negative the next and positive again and negative. Alternatively change the sign. Where you started as a positive, the next cell is a negative and then positive and negative. In this closed loop path, I have two positives and two negatives. Leave about positives and about negatives. Two negative cells are, one is for 20 allocation, another one is for 60 allocations. From the negative sign the cells, select the least value, that is 20 allocated over here. Now you have to do this 20, add where there is a positive sign, subtract where there is a negative sign. So my allocations, distributions get changed. Like first cell 20 need to add because there is 0 over here. Nothing allocated means you have to start allocating from here. This is the entering cell 20 and this is 20 minus 20, this becomes 0 and this is 100 and positive Now, whatever is not related to the closed loop, copy them as same. Firstly, there is a 16, S1, D1, allocated 180, it's not related to the closed loop. And second one, this is 14, this is 26, 24, this is 16 with the 90 allocated. And these four are changed right here. Firstly, this is the standard cell where we have a positive sign. Where there is a positive sign, we have to add 20 over there. The cost here 12. The next, there is a negative sign and it is 20, and over here is a 0 right now. Because 20 minus the negative sign element 20 minus 20, it becomes 0. And this becomes 0. And the next one, with the 8 rupees of a cost, you have 100, and right now if it is a positive sign, you have to add 20, 120. And the next one is again negative sign with the 60 minus 20, that is 40, with 18 rupees of cost. In the previous table, the allocation is over here, here and here. Now I made certain changes in the allocation, by that the total transportation cost minimized. That is. So we check whether the supply and demand constraints, rim conditions satisfied or not. This is 80 plus 20, 180 plus 20, 200, 120 plus 40, 160, and this is 90. This is 180. This is 120, 20 plus 40, 60, 60 plus 90, that is 150. 150 plus 120, 270, 270 plus 180, that is 450. Is the same problem? We have demand that. We have the match with the supply and demand rent conditions. Now calculate the total transportation cost. We see the differences. What we find out in the initial basic feasible solution and what we find out in optimal solutions are same, and what would be the change. Here the 16 into 180 plus 20 into 12 plus 120 into 8 plus 18 into 40 plus 16 into 90. Together, when you calculated all this, that will give you 16,000. Together, the transportation cost is 6,240. The one by using northwest corner cell method, I find out was 6,800. This is the difference between these two. Now, this is the final modified distribution of possible allocations made. I made previously by using northwest corner cell method. I made certain changes by using Modi method, and with that I am able to reach the least possible transportation cost called 6,240. The Modi method is simple when you understand the logic. The logic behind Modi method is change in the allocated cells. Possibly by that you can decreasing this total transportation cost. If not, then if you obtain the same 6,800 by using Modi method also means, that means the allocated cells is the maximum. You allocated with the maximum possible extent. If you change the allocated cells, allocated quantity to the least possible cost, then the total transportation cost may decreases. How can you find out that? By these occupied and unoccupied cells. Find out the unoccupied cells, opportunity cost. Where there is an opportunity cost is a least minimum. All these values must be greater than or equal to 0. If not, then there is a possibility to decrease to some extent. Firstly, find out these u, v values to the all rows and columns you have. Simply initially u1 equal to 0, and where there is a maximum allocations, that corresponding v or u values put 0 for calculation purpose. Both the ways you can prefer. After this, calculate the occupied cells values, Cij values. From the Cij values, calculate these unoccupied cell values. From the unoccupied cells, if all are positive, then N. Not if not, then select the largest negative value. That would be the entering cell. From there onwards, the cell being empty, that means not made any allocations over there. So here start and construct a closed loop path. Passes through all occupied cells and reach this started cell again. If not possible to construct a closed loop path with all occupied cells, you can bypass few unoccupied cells also, but no any addition deletion over there. You not to indicate sign or you not to add or delete quantities over there. Pass through all occupied cells and reach the started cell again, and where you started as a plus sign and automatically change the sign. The next cell is a negative, positive, negative again. And from the negative sign cells, select the least allocated value, that is 20 here. Where there is a positive sign, add. Where there is a negative sign, subtract. This 20 added, 20 deleted, 20 added, 20 deleted. Subtracted, sorry. Then the change, modified distribution would look like this. Now find out the transportation cost and compare. This is Modi method gives you two: checking the feasibility of the given obtained feasible solution, and second one, minimize the total transportation cost. That is our objective of constructing the transportation